This is day 3 of a unit in which we are working on solving systems of equation. The new element that we're going to start working on today is real world problems, or back in the day we just called these word problems. But the idea is some real world applications, although I'm not sure how useful some of these word problems would really be, but it's just to get us started in the world of these word problems. Okay, now let's get started. The key to solving these word problems, these real world problems, is the first thing I want you to do is to define your variables. So Jennifer is 6 years older than Sue. In 4 years, she will be twice as old as Sue was 5 years ago. Find their ages now. Now look, here's the key. This last sentence tells us what our variables need to be. Find their ages now. All right, whatever it is that we're supposed to find, that's what the variables have to be. So let's see, Jennifer and Sue. Okay, so I'm going to use J. So J will be Jennifer's age now. Okay, and I really try to avoid using S's because sometimes our S's look like 5s, but I'm going to go ahead and risk it this time. So we'll let S be Sue's age now. Okay, so I want you to define your variables right at the beginning. Now, if we're going to have a system of equations, that means we need to come up with a couple of equations. So let's just go one sentence at a time. Jennifer is 6 years older than Sue. Let's make an equation out of that sentence. Okay, so here we go. Jennifer is 6 years older than Sue, so that means J equals S plus 6. Jennifer is 6 years older than Sue. Okay, so that's our first equation. Now we need to make one more equation. All right, it says in 4 years she will be twice as old as Sue was 5 years ago. Okay, so we're talking about 4 years and 5 years ago. Okay. Okay, so it says in 4 years. So we're still talking about Jennifer. So look, what I like to do is I like to start off using words, and I sort of set them up in the form of an equation. So right here where it's saying in 4 years, talking about Jennifer's age in 4 years. So I would start this off just like this. Jennifer's age in 4 years. Okay, this is what we have at first. It's talking about in 4 years what's going to happen. So just write it in words for now. Jennifer's age in 4 years will be twice as old as, okay, so that means this should equal 2 times something because it's twice something. So I'll put a giant 2. Now twice what? Okay, twice as old as Sue was 5 years ago. Okay, so I'll put Sue's age five years ago. Okay, so let's just understand this. In 4 years, she will be twice as old as Sue was 5 years ago. Okay, so that means Jennifer's age in 4 years, okay, in 4 years, should be twice Sue's age 5 years ago. All right, that's what we're dealing with. Now, if you can understand that, like right here is where I lose many students. But if you can wrap your head around where I got this word sentence from, the rest I think you'll be able to do with no problem. Now, all we have to do is now go back and replace these word expressions with algebraic expressions. So, Jennifer's age in 4 years. Well, J is Jennifer's age now. So what would be an expression for Jennifer's age in 4 years? All right, that would just be J plus 4. All right, 4 years from now. And that should equal 2 times Sue's age 5 years ago. Now S is Sue's age now. 5 years ago would be S minus 5. So now I have an algebraic equation without all the words in it, but it's still saying Jennifer's age in 4 years should be double Sue's age 5 years ago. Now the hard part's over. The rest is just mechanically solving the equation as I know you know how to do. So, we might as well go ahead and do a little distributive property right now. Okay, get rid of these extra parentheses. So this is going to become J plus 4 is equal to 2S minus 10. So look, these are the equations that we have. We have this equation over here in orange, and then we have this new green equation. In fact, let me just bring this over. So we have J plus 4. Maybe I won't bring this over. All right, look, it's time to do our substitution. Okay, so this is what we're going to do. Substitution would be a good method to use on this problem because we already have J by itself. So we can just substitute this stuff in for J right here. Okay, so that means we have S plus 6 and then the rest of it. So plus 4 is equal to 2S minus 10. Now this has all S's, so I should be able to just solve this. No problem. So this is going to make S plus 10 is equal to 2S minus 10. Now, notice how I have S on both sides of the equation. Anytime I have the same variable on both sides of the equation, I need to get rid of one of them, and often by subtraction. So I either need to move this S over to the right or move this 2S over to the left. Because I like nice positive numbers when I can get them, I think I would choose to subtract S from both sides. All right, that gets rid of these S's, and so now I'm going to have 10 is equal to S minus 10. Okay? So this is looking pretty good. To get S by itself, all I have to do is add 10 to both sides. So plus 10 plus 10. So that's going to give me S equals 20. Okay? So remember, that's Sue's age now. So that tells me that Sue is 20 years old right now. Okay, but we're not finished. We also want to know what Jennifer's age is. So we will do substitution again by taking the answer that we just found, and we will take it and substitute it for S right in there. So this is going to become, all right, J is equal to 20 plus 6. Okay, so that means that Jennifer is 26. Okay, now as a final step, please, when you have a real world problem like this, we're talking about these Jennifer's age, Sue's age, put it back into words. All right, don't leave it as J equals 26. s equals 20, go ahead and follow through and write something like this. All right, Jennifer is 26 and Sue is 20 years old. Okay, that is the final answer. All right, I keep wanting to say any questions, but I can't hear you, so that would be silly of me. All right, let's move on, since I can't say any questions. All right, let's try a couple more. Let's look at number 2. Okay, 2 records and 3 tapes cost $31. 3 records and 2 tapes cost $29. Find the cost of each record and tape. So of course we need to define our variables before we do anything else. All right, we're talking about records and tapes. So I'm going to let R equal, all right, the cost of a record. And I'm going to let T equal the cost of a tape. Okay, this is what I mean by defining your variables, and you always need to do that right at the beginning of the problem. And one more time, it helps me if I want to know what the variables need to be. I look at the end of the sentence. I look for what are you being asked to find. Find the cost of each record and tape. So that's what my variables need to be, the cost of a record and the cost of a tape. Okay, now we need to create our 2 equations. So let's make one equation out of the first sentence. 2 records and 3 tapes cost $31. So let's see what that would look like as an equation. Okay, 2 records, so that's 2R, okay, and 3 tapes, okay, so that would be 3T, would cost $31. So altogether that would be $31. So there is my first equation. Now let's make a second equation. Okay, so now we need our second equation, and we will get that from the next sentence. 3 records and 2 tapes cost $29. So here we go, my friends. 3 records and 2 tapes, so that's 3 records and 2 tapes cost $29. Okay, so here are my 2 equations. This is my system. I need to solve it. Now, in terms of substitution versus elimination, which is also known as linear combination, which one of those 2 methods would be the best method for this particular problem? I hope you just said elimination. Why would substitution be a bad choice for this problem? That's exactly right. I'm assuming that you said, look, Mr. Burton, all the variables have numbers in front, coefficients. All right, the 2, the 3, the 3, and the 2. None of the variables are by themselves. None of the variables just have a coefficient of 1. So substitution would be very difficult with a lot of fractions. And we even have all the variables lined up nicely. So it's all about the elimination method for this problem. So let's do that. Now, for the key to the elimination method is we need opposites that cancel. So let's see what's what. It's really up to you whether or not you want to cancel out the R's or the T's. Imagine that you decided in your head to go after the R's. It just doesn't matter. But we need these to be opposites that cancel. So for example, if I turn this top equation, this top R into 6R, I could do that by multiplying by 3, because that would make 6r plus, and you know I'm doing the distributive property here, so that's going to be 6r plus 9t is equal to 93. Okay, but then I need the bottom equation to now be a negative 6r. So this equation is going to get multiplied by negative 2, because that's what it would take to give me that negative 6 that I'm looking for. Okay, so that's going to give me negative 6r plus, well, okay, not plus, minus 4t okay, is equal to, let's see, negative 58. So now we can go ahead and combine like terms. Of course, these are opposites just like we wanted, so they cancel. 9t minus 4t is going to be 5t equals 35. Dividing both sides by 5, we find that t is equal to 7. Okay, so that means a tape costs $7. Do you guys even know what a tape is? Tape. Long time ago, they had these things called tapes. They were like long, stringy MP3 recorders. Anyway, we need to take the 7 and substitute it for t. Now, I could really put it into either one of these two equations. I'm going to use this green one because it's right here in my face. So this is going to give me 3r, I'm just copying this down, plus 2t. Now t is 7, so I'll just go like that, is equal to 29. Okay, so that's going to give me 3r plus 14 is equal to 29. Subtract 14 from both sides. So that's going to give me 3r is equal to 15. Divide both sides by 3. So I get r is equal to 5. Records, man. Who is still using records? DJs. Some DJs are still using records. Real old school DJs. But do you know what a record is? I play this game with my daughter all the time. Every time we watch a movie from like the 80s or the early 90s, when they're walking around, when they're on phones that are still connected to the wall, and like back in the day, the phones used to all connect to the wall. You couldn't walk all over the house. Oh, that's a record. I had to tell her what a record is. She goes, Dad, I know what a record is. Just let me watch the movie. Anyway, don't forget to convert these back into words. So the cost of each tape. So we would say tapes cost $7 and records cost $5. Alright, and that is the true answer to the question. Go ahead and put it back into words. Okay, how many more of these do we have? Is that really only number 2? I feel like this is taking forever. Okay, we got 3 more problems to go. I'm going to see if I can speed up this process. Now that we've had some practice, maybe now that we know what we're doing now. So let's see if you can follow me if I work a little bit faster. A shipment of TV sets, some weighing 30 kilograms, others weighing 50 kilograms, has a total weight of 880 kilograms. There are 20 TV sets altogether. how many weigh 50 kilograms? Okay, so there's two different kinds of TV set, and we're talking about how many. So the variables should be like this. I'm going to let X be the number of, let's see, what do they say first? 30 kilogram TVs. And I'm going to let Y be the number of 50 kilogram TVs. Okay, two different kinds of TV. Of course, we want to know how many weigh 50 kilograms, so in the end, we're looking for Y. Now, we need to see if we can get two equations out of this. Let's see, where are the equations? Okay. All right, a shipment of TVs. Okay, so I see one equation in this area right here. Total weight of 880 kilograms, all right? All the TVs, okay? The whole shipment has a total weight of 880 kilograms. Well, that total weight should be the weight from the 30 kilogram TVs plus the weight of the 50 kilogram TVs. So if X is the number of 30 kilogram TVs, then 30 times X should be the total weight of those TVs, okay? Because this is how many. If there are 10 of these, then it'd be 30 times 10. You know, if there's 20 of these, then that would be 30 times 20. So this weight times how many, that should be the weight of that type of TV. So plus 50 kilograms per, 50 kilogram TV. So this is the weight, total weight of the 30 kilogram variety, total weight of the 50 kilogram variety should add up to the overall total weight of the shipment, which is 880 kilograms. So that is the first equation. Now, can we get another equation? Okay, there are 20 TV sets altogether. All right, well, this will be a nice, easy equation. Let me highlight it for you so you can really see what's up. 20 TV sets altogether. Well, there are two types of TV sets, X and Y. If it's a total of 20, then that makes for a nice, simple little equation, which is this. X plus Y equals 20. All right, there's this many of one type plus this many of the other type. The total should be, there's 20 of them, so X plus Y equals 20. Now, I could put this under here and do this by elimination. I could go X plus Y equals 20, and then I could multiply, say, by negative 30 and cancel, and I could do this by elimination. Or I could get one of these by itself and plug it in. I could do substitution. So you could really do this by either method. I'm going to go ahead and do this by elimination. Wait, that's 20. All right, so eventually I want the Y, so I'm going to cancel out the X's by multiplying this by negative 30. Whoa, that's off camera. Whoa. Let me bring it over. So if I multiply this by negative 30, then let's see what we get. Okay, I feel like I need to recopy. Alright, so look, the original equation up top here was 30x plus 50y is equal to 880. Now I multiplied this equation by negative 30, so that's going to give me negative 30x. Alright, this is coming like here. Negative 30x minus 30y is equal to negative, what's this, 600. So if you go ahead and solve this, those are going to cancel out. 50 minus 30 is 20y, all right? And that's going to equal to 280. And then, of course, I would go ahead and just divide both sides by 20, like this. Okay, so those are going to cancel out. So that's going to give me y equals 14. So there are 14, and y was the 50 kilogram type. So how many weigh 50 kilograms? 14. Yeah, so to put it back into words, you could say it like this. There are 14 50 kilogram TVs. Okay, and that would be like your final answer. All right, just a couple more left. All right, just 2 more left. We can do this. Okay, the sum of 2 numbers is the same as 4 times the smaller number. If twice the larger is decreased by the smaller, the result is 30. Find the numbers. Find the numbers. All right, that means our variables need to represent the numbers themselves. And let's see, how can we break it down? There's there's a smaller number, and then there's a larger number. So I could either use X and Y, or I could use like L and S. Doesn't really matter. I'm just going to use L and S. Let's just keep it real. Let's keep it real. Okay, so I'm going to let S equal the smaller number, and I'm going to let L be the larger number. Okay, big shocker, big shocker. Now the equations. Okay, the sum of 2 numbers is the same as 4 times the smaller number. So I'm going to write an equation from that sentence right there. The sum of 2 numbers. So that means S plus L, it's the sum of my 2 numbers, is the same as, in other words, equals 4 times the smaller number. So that's 4S. So that's my one equation. Now I need my second equation. Okay, so for my second equation, I am going to do this sentence. If twice the larger number is decreased by the smaller number, the result is 30. So that equation would look like this. Twice the larger number, so 2L, is decreased by the smaller number, so that's minus smaller number. Decreased by means we're subtracting. The result is 30, so that should equal 30. Now warning, be careful. Look at this equation. See how I have the variable S on both sides of the equation. Whenever you have the same variable on both sides of the equation, you need to get rid of one of them. In this case, I would get rid of this S. Since this term is over here by itself, it will be confusing if I get rid of it and have 0, and a lot of kids get confused. So I would subtract S from both sides. So that's going to give me L equals 3S. Alright, so this is the equation that I actually have now. So clearly this is a perfect situation for substitution. Alright, because I have L now by itself, and I would go ahead and take this and substitute in for L, and it is a thing of beauty. So this is going to become All right, 2 times 3s minus s is equal to 30. So that's 6s minus, all right, these are s's, not like 5s or anything. So I've got 6x, s minus s is equal to 30. All right, of course that's 5s. And I'm going to try to make them look different. Man, I do not like using s's. And now I'm going to divide by 5 on both sides. Okay. So s, the smaller number, is 6. All right, now let's substitute that in. All right, we'll take this s that we just found and put it right there. Okay, so that'll give us L is equal to 3 times 6, or L is equal to 18. All right, all that's left is to put these answers into words. So we will say like this. The smaller number is 6, and the larger number is 18. Okay? And that is how you would do number 4. Okay, number 5. A coin jar contains only nickels and pennies worth a total of $5.27. If there are 195 coins in the jar, how many of them are pennies? Okay, so this last statement gives me a clue about the variables. How many are pennies? So that's the number of pennies. Okay, so I'm going to let P be the number of pennies. Okay, but it also talks about nickels. So I'm going to let N similarly be the number of nickels. Okay, now I need 2 equations out of this. Let's see how we do. Okay, worth a total of $5.27. So we can get our first equation from that, the value of this money. Okay, well, pennies. Okay, a penny is worth 1 cent. So that is 0.01. All right, that's 1 cent. So we have 1 cent for every penny. Okay, a nickel is worth 5 cents. Okay, that's $0.05. Okay, that's 5 cents. So 5 cents for every nickel should give us the total amount of money, which is $5.27. Okay, so that is the one equation. Now, if there are a total of 195 coins in the jar, so that's where my second equation is going to come in. Whoops, I meant to be using the highlighter tool. So there are 195 coins in the jar. That is going to give me my second equation. Okay, because we just have pennies and nickels. That's the number of coins. So if the total is 195, that means the number of pennies plus the number of nickels should equal 195, the total number of coins in the jar. Okay, so we have our money equation and our quantity equation. Okay, I think I will just do substitution. There are ways I could do elimination, but I think I'm just going to do substitution on this one. Now, I want to find the number of, let's see, pennies. I want to find the number of pennies. So in that case, I'm going to actually get n by itself. And you'll see why in a second. So I'm getting ready to do my substitution now. So for substitution, I have to get one variable by itself. And it turns out that if I want p, I really want to get n by itself right now. And here's why. If I subtract p from both sides, so I have n equals, I could either put 195 minus p or negative p plus 195. I'm just going to put negative p plus 195 because that's what I'm used to. Okay, I got n by itself. I'm trying to find p, pennies. But here's why I did it that way. Because I know that when I substitute, it's this stuff over here that's going to stay in the equation. Because I'm going to take all this, and let's see, I need to put it in for n. Okay, so I'm taking this and I'm using it to replace n right there. Okay, so I got n by itself, so that means n gets replaced. So this equation is going to become, okay, 0.01 p plus 0.05 times parentheses. All right, I use parentheses when I substitute, equals 5.27. And inside the parentheses goes my negative p plus 195. So if I do a little distributive property right here, okay, that's a positive times a negative, so that's going to be minus 0.05 p. Okay, now it's just a matter of what's 0.05 times 195. That turns out to be 9.75. And I'll just bring down everything else. Okay, so 0.01 p minus plus equals 5.27. All right, notice I have all p's, so I should be able to solve for the number of pennies. All right, well, we've got like terms here, so we need to put those together. 0.01 minus 0.05 is going to be negative 0.04 p plus 9.75 is equal to 5.27. Got to get this p by itself, got to subtract this. Okay, so these are gone. So let's see. 5.27 minus 9.75, that's going to be negative 4.48. Now I just need to divide both sides by 0.04, like this. Okay, dividing by negative 0.04. Alright, that way these will cancel each other out. Alright, so that's going to get me P equals 112. Okay, so of the 195 pennies, 195 coins, 112 of them are pennies. And don't forget to put that back into words like this. There are 112 pennies. Okay, and that is a good introduction to how we handle real-world problems with systems of equations. And we'll have more practice on this in future lessons, so stay tuned, keep coming back.